I want to talk about, in section 1.2, piecewise functions. So simply put, piecewise functions are defined in, get this, pieces. So if you're looking at a graph, you might be looking at a function that takes on characteristics of, let's say, a linear function. So let's say we have a linear function that's increasing, so positive slope, right? And then it takes a little break. And then it becomes not a linear function. As a matter of fact, let's say it becomes a quadratic. So let's put that right there, and then like that. And let's say that's what it is. So we have two pieces to this function. In this case, one is linear, and the other is quadratic. Now, the key thing to remember here is at some point this changes. Remember, we have a series of inputs, and everything depends on those inputs, that is the x values. And what that means is we have our function values, f of x, aka y, right? That means that there's a certain x value where this thing changes, right? Where that x value is, well, it depends on the function. Now, there is something, and it's not very clear here, so let me clean something up here. It's a slight mistake here on my part. When you are looking at a piecewise defined function, it needs to be a function, which means it needs to pass the vertical line test. So if it's linear up to this point, let's say it's including that, that means if I were to draw a vertical line, I couldn't have it overlap. So what this means is that we have a point where it's undefined. Now this is what this would look like. So let's say this is some function, right? And I'm just making up values here. But what it is, it's going to be linear, which means it's going to have two pieces. Back that up. Back that up. There we go. So fx is going to have two pieces in this case. One's part's going to be linear, and it's going to be defined in terms of where this x value is. So let's say that it's linear, and let's just, I don't know, make something up. Let's say it's 2x plus, I don't know, 7, right? Y-intercept looks like it's up there somewhere. And that would mean that it's going to be that when x is less than x sub 1, right? We'll look at some actual numbers here, make it a little bit more easy on ourselves. But then what happens, now we should say less than or equal to though, because it's actually at x1, it's equal to that. And then after that, so when x is greater than x sub 1, it ends up being this quadratic. So let's say that that's a quadratic, I don't know, how about x squared minus 2, right? So a piecewise defined function is simply something that is defined over a certain domain. So these are the domain. Okay, so let's take a look at another example, but looking at it the other way. What if we had a function, g of x, such that it is x squared when x is less than, I don't know, how about -1. And then it becomes about -3x plus 2 when x is greater than -1. Now, we do need to make a decision here. We have to have this thing stop being something and start being something. So we'll go ahead and say greater than or equal to, which means it takes on this 3x plus 2. Now, if forced to graph something like this, without technology, you would have this critical point here, which would be -1. And it's going to look like x squared up until that point. So if we think about what x squared does, and please bear in mind this, it means that x squared is going to be some graph coming down like this, right? And it's going to be at 0, 0. Does it have a value at -1? In other words, what we're going to need to do is figure out what it is at -1. And we happen to know that that's going to be 1. Why? -1 squared is 1. And that would mean after, or sorry, before -1, it would look like this. A quadratic. Well, part of a quadratic. Now it says strictly less than. So is it actually that at that point? The answer is no. So we'd actually use an open circle to define that, meaning it's not that. Then -3x plus 2. Well, we have to do the same thing. We're going to have to figure out what -3x plus 2 is at that point. It's our point of interest. So that would be 3 plus 2, or 5. So that means way up here, the graph is not to scale. that would mean that this thing is going to be negative 3x plus 2, which means it's equal, so that means it's going to be actually take on that value. This way it passes the vertical line test, right? And we happen to know that it's got a y-intercept of 2, so it's going to cross through a 2 here and be a linear equation going down. So what we've got is a quadratic, not the greatest quadratic, but a quadratic, and then a linear equation all smushed into one graph, or piecewise defined. And that's it.